Welcome back to Course 1, Lesson 23 for Saxon Course 1 Math. Lists two terms at the top that look very similar, seem very related, and they are. So maybe a focus for today's lesson, how are these terms related and in what way are they different? First of all, the big term everything else is going to have to do with is the word ratio. What do you know about ratios? Have you done these before? A ratio is a way to describe a relationship between numbers. They can be written any of three ways. You've got using the word 2, 13 to 15. You can use a colon like this here, like it looks like a time, but it's not 13, 15 o'clock. It's saying 13 to 15. Or the one we're going to focus on today, what does this look like? Fraction form. Any of these reads the same way, 13 to 15, quote. But in this lesson, we're going to focus on that fraction form. That's the most common, and we read it top to bottom, maybe using the word to or even per when we get into rates for that fraction bar, that bar like this. And it could be 2 to 5, it could be 6 to 10. Now, when you reduce a number, you do it just like it's a fraction, because that's really what they are. So how could I reduce 6 to 10? I would call that maybe better 3 to 5, divided both top and bottom denominator by 2. The 13 is called a term in the ratio. A 15 is called a term in the ratio. Leave it in fraction form. Don't change it to a mixed number, even if we have an 8 to, say, 3 ratio. Let's say we have 11 kids in the class, 8 boys, 3 girls, and we're asked to give a ratio of boys to girls. Notice first, I always put in the order we were given, boys to girls, top to bottom. Boys to girls, 8 to 3, not 3 to 8. Stay in order. And since there's more of boys than there are girls, we're going to have a bigger top, a bigger numerator. Don't change that into 1 and, what would we have? Actually, it'd be 2 and 2/3. Don't do that. If you can't reduce it, leave it as 8 to 3. Again, another way to show it would be like that, but we focus today on that style, that fraction style. Example 1 says, a team lost 3 games, won 7. What's the team's win-loss ratio? On TV, you'll normally see that listed like that. Okay? But how do we write fraction ratios according to our lesson? It's a fraction, 7 to 3. They said win-loss, so win goes first, so it's on top. Loss, 7 to 3, is our ratio. It compares, it shows relationships between numbers. Is the win-loss going to be the same as loss-win? It says no, because then it would be 3 to 7. Order does matter according to those numbers 1 through 3 rules for ratios on the previous page, right? Class of 28 students, 13 boys. What's the ratio of boys to girls? You might say, well, they didn't tell us how many girls there are, but they did. In what way did they tell me in this sentence, yes, this sentence, how many girls are in the class? Pause if you need to think about that. But I'm going to tell you, we know there's 15 girls because there are only 2 genders, and 13 means 28 minus 13 is 15 are left, and unless we're counting animals, those are human girls. 15 girls. So now, what's the order? Boys to girls, 13 to 15 girls. You don't have to label those, notice. Now, a rate is just like this. We're not learning something drastically different, so don't worry. Rate just means let's talk measures, all right? Here are some common ones. For speed, we have miles per hour, sometimes shown as mph. Mileage is distance over fuel use, so maybe miles per gallon, oftentimes used when you're shopping for a car, what's going to get the best fuel efficiency. And unit price, price over quantity, like $2.89 per pound. And notice you can write it typically this way, or there's an alternate form there. Notice in each of these cases, instead of reading the line, the fraction bar, as 2, Now we use the word per, which really just means, I guess, for each. 28 miles for each gallon. But when you read these, you say the first quantity per second quantity. Okay? Read that fraction bar as per in a rate. 55 miles per hour. And in these cases, you will want to label these because we want to know what we're measuring on top and on bottom. In a rate problem, one of the numbers will be unknown and we'll have to solve for it. Find it by multiplying. On a bike trip, Jeremy rode 60 miles in 4 hours. What was his average speed? We want to get the ratio so that it's a 1 in the denominator. So 60 to 4, we're getting good at that. Label it so we know what's on top and on bottom. And since 4 goes evenly into 60, we're actually going to solve this by dividing 4 into 60. And in your calculators, you'll find this fits in once, leaving me 2, 0. That goes in 5 times to make an even 20. So 15, label it miles per hour. We would maybe put it like this, miles per 1 hour. Okay, we basically just reduced this down to look like that. Let's do one last one before lesson practice. Mr. Moskow's car averages 32 miles per gallon. It's already down to a reduced rate per 1 gallon. We don't have to do any dividing here. Predict how far he can expect to travel on a road trip using 10 gallons of fuel. Well, if you get 32 miles for 1 gallon, and we're going to use 10 gallons, how many miles? Just multiply your 32 by the 10 gallons, and you get 320. So in that case, we use multiplication to solve an estimate problem. You can make a table to help solve and visualize this. Read through that one in your book on page 124. Again, if it doesn't make enough sense, or if you need to go back, you can always watch more of this video. Let's do A, B, C, and D. A, B, C, D. Thank you.